Welcome, lazy chemists. Today what we are going to be doing is we are going to be taking a penny and we are going to slowly turn this penny into an alloy over the next couple of days. First, what you want to do is find the nicest, shiniest penny that you have, and you need to get a pair of tongs. You will take your penny and you're going to vigorously scrub it to try and make sure that it's the shiniest penny that you have ever seen. Okay? The reason that we're struggling to get all the little dirt and grime off of it is because that dirt and grime will stop us from being able to plate it with zinc, which is what we're going to be doing later. Then what we'll do to help us with our penny is we'll go ahead and take a flask like this. We'll take an Erlenmeyer flask. We'll drop our penny in. Then we're going to go ahead and cover the penny with vinegar. Okay? Vinegar is also known as acetic acid. We're going to cover it with vinegar. Then we're going to go ahead and take a Post-it note. We're going to put it right on our beaker. We're going to tape it down. We're going to write our names on the Post-it note. And once we do that, we're going to let this sit for at least 24 hours so that we can go ahead and make sure that the surface is completely clean. Alright, welcome back, lazy chemists. Today what we're going to do is we're going to go ahead and make a non-concentrated batch of hydrochloric acid. The way that we're going to do that is we're first going to pour some hydrochloric acid into our beaker here. Then we are going to pour from our beaker into our graduated cylinder here. This is a dry graduated cylinder. It has no liquid in it. And then we are going to close by pouring it into our distilled water right here. A couple of things to note. You should always add acid to water and not the other way around. Otherwise, you are going to get a very quick exothermic reaction that will burn. Okay? It'll be burning all over. When working with concentrated hydrochloric acid, you need to beware of fumes, which is why we're in the fume hood. We've poured out about the right amount. Come a little bit closer. Now we've poured out 100 milliliters. Notice that we're always going to make sure that our line is right at the bottom of 100 milliliters. And we will slowly pour this into our distilled water. Notice that you can see the fog. That would be the acid fumes that are being released. This is a very warm container at the moment because of that. We're going to measure our next 100 milliliters. as you note, we are just a little bit short. In this case, what we're going to do is we're going to just mark off how many milliliters that we have. And the reason that we're going to mark that off is because we don't need to have the exact amount. We just need to know how much we have. And in this case, we have 79 milliliters, which means we're adding 179 milliliters of 12 molar hydrochloric acid. We are going to go ahead and leave our main acid body there. We're going to move this over here. Okay. The last thing that we are going to do is we are going to go ahead and top this up. We're going to top this up till it's at the 500 milliliter mark. Okay. And now we have our concentrated batch of hydrochloric acid. At this point, we will be able to go ahead and start doing the math to figure out how many moles of hydrochloric acid we have. So that way we can figure out how many moles of zinc we need to add to make zinc chloride. This should close us out for the Lazy Chemist for today. Hello students, and welcome to the second part of the Penny Lab. And the second part of the Penny Lab is going to be where we take hydrochloric acid, and that's what this substance is right here. Okay, notice it looks like water, so if you see something that looks like water in a chemistry class, you should immediately be suspicious because it is not water. Okay, and what we're going to do is we're going to take this hydrochloric acid and we're going to make from it a solution of zinc chloride. All right, so I'm going to go ahead and write down the formula or the equation that we're going to use for our first reaction, and we're going to take zinc, and to this we're going to add HCl to it. All right, now from this we're going to make zinc chloride plus hydrogen gas. Okay, so this is our equation that we are going to be working with here. And I want you to note a couple of things. First, on this side we have one zinc, this side has one zinc, this side has one H, this side has two H's. Okay, so that means that we have too many H's on this side that we have to go ahead and cancel out. So we're actually going to go ahead and put 2 right here. And this means that the zinc is going to react with a 1:2 ratio to the hydrochloric acid. Okay? And so now everything should end up being balanced. All right? So this was a very easy formula for us to go ahead and balance here. Now, the reason that we needed to balance this formula out is that we are going to be measuring out 30 milliliters of hydrochloric acid, and we need to figure out how many moles of zinc that we need to add to it. All right, this is kind of a preview for what we're doing next week. So what we're going to do is we're going to go ahead and first convert this into moles, okay? And we need to know the concentration. All right, and I happen to know that the concentration is 3.5 molar, okay? Which means that it's 3.5 moles over liter, okay? So we have 30 milliliters of 3.5 molar HCl. Now, we need to go ahead and get it to moles. Why do we need to get it to moles? Because we always need to get it to moles. Okay. So we're going to go ahead and put moles over liter. And then what we're going to do is we're going to go ahead and write what unit we need to get to moles. Okay. And this one's a fairly easy unit that we need to use to get to moles. We have to put liters right here. All right. So we're going to put liters right there, and that'll cancel. Now the number that's going to go with liters is going to be this one here. Okay. It's going to be our volume, which is going to be 0.030 liters. A reminder, milliliters is simply a partial, is 1,000 milliliters equals 1 liter. Okay, so we're going to go ahead and multiply these two together. And then what we have to do is we're in moles, and we're going to go ahead and compare the moles of HCl to the moles of zinc. So we have to find out how much zinc we have to add to cancel out all of this HCl. So that means that we're going to want to get rid of the HCl and then add zinc. Okay? And 1 from the balanced equation goes for zinc. And here this 2, this magic 2 that we did when we balanced the equation, is going to go for HCl. Okay? The very last thing that we're going to do is we're going to add the right amount of moles of zinc. However, one thing that we should note is that the only way that I can add zinc, that I can figure out how many moles of zinc I have, is by adding or using the molar mass of zinc. Okay, so we're going to go ahead and go out of moles, okay, because right here we're in moles, because this is our unit that we have here. And we're going to go to grams. Okay. So this right here is our formula for figuring out how many grams of zinc we need to add to 30 milliliters of 3.5 molar HCl to make our zinc chloride. All right. So now I'm going to go ahead and head to another. Okay, so I've went and done all of my math, and it looks like I'm going to need to get 3.33585 grams. So I'm going to first measure out. My hydrochloric acid. Okay. Okay. So I have 30 milliliters here. Okay. We have 30 milliliters here. And then we have to go and measure out 3.5 grams, or in this case it has to be at least 3.5 grams. So we're going to go ahead and come over here to our balance. We're going to tare it. And we need to have at least 3.5 grams. I'm going to do this the lazy chemist way. This is a case where it can be over, but it can't be less than. Because we just want to make sure that we're... Okay, that was a little bit much, but... Okay, so we have 4.9. Seems a little bit much. 3.9, that's good enough. Okay, this is one of those experiments that we just want to make sure that we have access. So we're going to come back over here. And I want us to note here that we're going to be expecting something. So here in this reaction, it says that we're going to make H2. Now, that means that we should expect to see something in this chemical reaction. So we're going to go ahead and dump this in here. Okay. We'll go ahead and give that a stir. And as you guys should notice, we start to see some bubbles there, all right? So those bubbles are going to end up showing our H2 being made. Okay, and this reaction is going to go ahead and take some time to develop. It'll take a little bit of time for it to go through, which is why the classes had a couple of days of prep for this one lab here. One thing that I want you guys to note is that at the end, our solution is going to end up looking like this. Notice that there's a little bit of zinc still at the bottom. That's because we wanted to have some excess zinc in order to make sure that we reacted it fully. Okay. This is going to close this portion of the lab until we finally move on to the point where we're going to actually coat the penny, which is to take a look at our actual penny. So we're going to go ahead and grab a funnel. Okay, we're doing the funnel to go ahead and take out our penny. And as you can see right here, maybe if my camera isn't made out of kitchen twine, is that our penny is no longer silver, or it is no longer coppery, but our penny is now instead a nice silver color. Okay, what we're going to do now is we're going to go ahead and dry the penny and then weigh it. Okay, we have now weighed our penny, and we have 2.4665. Which means that we will be able to figure out how much mass of zinc was added to our penny. The final step for us to do is to heat up our hot plate so that we can finish with the penny. All right, the last thing that we need to do here is heat up the penny so that we can cause it to go into its alloy form. And in order to do that, we're going to take a hot plate. So right now this hot plate is hot. We're going to take our penny and we're going to place it on the hot plate. And as this goes through and as this heats up, what you'll notice is that we should see a nice change in the color of our penny. And you should see that the penny has now turned golden. Okay, so now we have a nice golden penny. We put it in the water so that it can cool down. And you can see here now that we now have a beautiful golden penny that is now an alloy. From this point on, you should be able to do all the lab report and be able to solve all the questions for this section. Let's go ahead and dry it for a second. And it looks like we have 2.465. So 2.465 is going to be our final amount that we have added to it. And that should close us out for today.